Okay. Um, we are doing cheapest flights within K stops. There are n cities connected from some number of flights, connected by some number of flights. You are given an array flights avoid to from price. So basically, list, मतलब, a list of two from flight, and this is the weight. This is like the start node, end node, or parent node, child node. Indicates the flight. Okay. You are also given three integer SRC distance k. Return the cheapest flight with at most k stops. If there are no such route, return one. At most k stops. Okay. So one, two, one, two, three. Okay. One, two. So DFS or BFS? BFS. Okay. We do BFS. And if this is not found within k stop, we return -1. We could got it. I think I got it. So 0 to 1, it will take 100. Then in this will reach in one stop. This will reach in two stops. We do this till we reach K, I guess. We reach K or all the nodes are empty. Cool. So do I make a adjacency list? Yep. Vec map int comma int vector int mp. Okay, so now for int I vector parent of I is equals to 0, I smaller than uh, I I plus. Okay. Now MP of rather than this int x of nights x of 0 is equals to x of 1 comma x of 2. Cool. So we have this directed edge that we have made. Now let's add source. So how will this work? So we have to do BFS because will not help us with so vector int visited of size n rule visited of src is equals to 0. Cool. Visitor of SRC is equals to QUE, and Q is equals to Q, Q dot push, Q dot push SRC while K greater than equals to 0, and then not Q dot EMP TY. So in one step, create greater than equals to 0 or create greater than 0. Create greater than 0. Okay, cool. Mm, Now int s is equals to q dot size for int I is equals to 0, I is smaller than s, I plus plus. Uh, okay. Now we take out this element, so int node is equals to q dot top front, q dot pop, dq, and let's dq, q dot pop. So we have the front node. Now let's just go into its neighbors. So oh, let's comma int max. Okay. Int I is equals to 0, I smaller than empty of node dot size I plus plus all the elements that are its neighbors. Now if visitor of auto any IGHPOU are neighbor of empty of node. mm, If visitor, so we get neighbor and index is equals to neighbor dot first int weight is equals to neighbor dot second. If visitor of index smaller than visitor of node plus weight with the index greater than, then we'll go look up this. So visitor of index is greater than visitor of node plus weight. Then at that point, Should I use a priority? Visitor of node plus weight, then q dot. So viz of index equals to visitor of node plus weight and q dot push index return dst. Visitor of dst equals to mm, max and minus one as visitor of dst. Should work. Auto dot push back the 400. Okay, so I'm not doing K minus minus. K minus minus. Dot normal BFS. And it goes to 4. That goes from 0 to 1, 0 to 2. Okay, so uh, See, k is equals to 1 right now. K 0. Hmm. So 0 will be 1 and 2. Push 1. Now this will push 2. Which is good. Now there are no more neighbors, I guess. Yep. It comes back to the top. Mm, I s- it back come back. Yeah, good. K is equals to 0. It can do one round, I guess, which is good. S becomes 2. Node is 1. Popped out. One say we go 2. This changes to this is a problem. I don't want it to change this now. Should I do a depth first search? I should do a depth first search, but I think I should look at the editorial only. BFS. um, Okay, so in the queue only they are storing distance. The queue only they are storing distance. Comma 0. Uh, First, good, good, good. B plus C. Good. Network delays time. It's the extra only. That create calculate the extra and then calculate the maximum out of all, I guess. Yeah. So I'll leave this. I know how to do this. I'll leave this out because not DFS, not not BFS. BFS, I think for the extra, I feel BFS that's much better. The extra, use the extra and then just calculate. They are creating priority queue, and yeah, basically in this they calculate the and then they calculate the maximum. Good, exactly what I said. 743.
I want to thank you from the bottom of my heart. Okay, collect.
Luka Jaja need Luka Jaja needs 220. Yeah, I'm happy. I'm happy. I'm happy. I'm happy. Hey, I want to see that.
I want to thank you.
I like three languages: Java, Script, C++, and Golang. These are Rust also. So four languages, but Rust I don't know. Rust is something that I would like to learn. Uh, 740 something. 746? 746. Let's see. Where was it? 743. Save. Save. Hey, you can't. I'm crazy. Oi, oi, oi. Analytics are getting better. Uh, Female, male, neurospecified. India, US, Canada. No, India, US, Canada still don't make like 50, around 50, 60%. Around 60% of my audience makes India, US, Canada. But 40% comes from other geographies. So 65 for live content, video search, browse features. Okay. I'm very loyalty. Good, good, good. Uh, it's interesting to see all this. It's very interesting when I see this. This was the point when I started. There have been ups and downs. 202 has been the highest, I guess. But 231, it will this catches up, I guess. It's for December 22, 2023. So, oh, last 48 hours. Okay, got it. Nice to see, nice to see. Cool, cool, cool. Number of ways to arrive at destination. Number of ways to arrive at destination. And you are in city that consists of an intersection number from 0 to n minus 1 with bidirectional road between some intersections. Okay. The inputs are generated such that you can reach any intersection from any other intersection, and there is at most one road between two intersections. Okay. So you can reach from any intersection. You are given an integer n, a 2D integer array roads, where roads of I, UV, and time. Okay. From means, is there a bidirectional road? Yeah, I think there is a bidirectional road. How many ways you can travel from intersection 0 to intersection n minus 1? The shortest amount of time. 4. So n minus 1 is 6, I guess. Yeah. So 0 to directly 6 will take 7 amount of time. So if it be Dijkstra, I get this 7. Okay, cool. Then this I find is equals to again 7. So I add the count to 1. Then this also I find to be 8, which is greater. So gone. So gone. And this 3 1 1 2 3 1 1. So this I again find 7. So I add a count again to 1 plus 1. And 2 3 1 1 again. So count plus plus. So every time I get the minimum count, I increase, I guess. And if I get a number that is lesser than, then I make the count as 1 in that at that point. So yeah, basic Dijkstra plus some extra logic. Uh, let's see. I don't think we need an array also. Do we need an array? Okay, I think we do also need an array because let's say there was another way to reach 4, which took 5 only, but this will only give us 1. So we need to account for that. Simple, not that hard. Let's just read the code and move on from this problem. 1976. Ah, so they have made, and that's just the extra. Uh, distance, ways, priority queue, 0 0. Distance to greater than equals to time, then equals to. ways of you. And if it is greater than this, if it's equals to, then we add the ways of both plus equals to, and we do a mod. Not that difficult. Minimum multiplication to reach end. I'm kind of tired now. Three questions are good, but we can do more, I guess. Minimum multiplication to reach end. Just start and an array of n numbers. Okay. Each step start is multiplied with any number in the array, and then mod operation of this x is done. Get a new start. Okay. The task is to find the steps in which the end can be achieved starting from the start. It is not possible to reach the end. So, okay. So I multiply start I can multiply by 2, 5, or 7, mod it by this, and get the end number. Then whatever I get, I multiply it again by 2, 5, or 7. So proper BFS. So if it is smaller, I can't understand the false condition. What could happen that it reaches 31. Okay, let's say. In this case, it reaches 32. 32, because it's a multiple of 16. And then there is a number which makes it a multiple. So 100,030, 100,030 divided by 32, 33, 34, 35. So 35. Let's say it reaches 35. And now there is this number which can make it, when we do mod, we get 30. So 35 in that number, and then we do mod by this, so we get 30. So, so we can't do that. If a number reaches greater than 30, we mark it as stop. What is the stopping condition? When do we say that, okay, we have to stop? 1 points, 4 points. Oh. Ah, stopping condition, stopping condition, stopping condition. Chat, can you think if there is a stopping condition? I'm a little tired. I'll come back, I guess. 45 minutes is okay. I think I can do 3 questions in 45 minutes. Though I haven't coded. At least I can do 2 questions.